Alioramus merch is now available on the Edge Redbubble. Support Edge and all the artists I work with by following the links in the description and comment section below. Tyrannosaurs are an impressive group. To our society, they represent raw power and the unrestrained tenacity of nature. However, they were a successful group of animals just like any other, and were lucky in that their rise to apex-predatory was paved for them with the extinction of the larger hatchet-faced theropods they lived with. Over a rather brief period of geologic time, they expanded their territories from Asia to Europe to North America, and burgeoned into some of the largest, strongest bipedal carnivores to ever live. There are plenty of stops along the way of this group of tyrants that remains a bit of a mystery, even when we have a good amount of leftover remains. Prepare to come face to face with just one of those mysteries of tyrant history, none other than the Mongolian mystery monster, Alioramus, the Strange Branch. Mongolia has long been known for its diversity of fossil fauna. In certain places in Mongolia, like the Flaming Cliffs, you have to watch where you step because you could easily step on any assortment of fossils, eggshells, small-horned dinosaurs, strange birds, tortoise-like animals, and any number of other antediluvian beasts lay as they did when they died millions of years ago, now trapped within an earthen tomb waiting to be uncovered by the elements, or a curious paleontologist. The exploits of the real-life Indiana Jones, paleontologist and adventurer Roy Chapman Andrews are legendary. However, Mongolia has produced fossil material for centuries and will do so for centuries more. And Andrews was neither the first nor the last expeditioner to uncover the secrets of the sands. During the 1970s and 1980s, expeditions were taken to Mongolia by many museums and institutions. And since one of the closest regions to Mongolia, with plenty of paleontologists at their disposal, is Russia, there were many Soviet teams out there looking for new material. One such expedition was the joint Soviet-Mongolian paleontological expedition made in the early 1970s. This expedition to the Gobi Desert went to the Bayankhongor Imag province of Mongolia to a locality called Nagan Sav. This locality is mostly sandstone and clay deposits, and it is from these red-colored beds that a new tyrant dinosaur was unearthed from 1969 to 1973. Paleontologist Sergei Kurzanov named a set of remains found in the locality Alioramus remotus, which translates to removed other branch, due to the way in which it might place phylogenetically amongst its relatives. These remains consisted solely of a partially preserved skull and a few toe bones. Though incomplete, it fortunately preserved a skull, which allows researchers to pinpoint more easily what exactly this thing is. Kurzanov placed it within the Tyrannosauroidea, which is a supergroup including all of the tyrannosaur-like animals, both advanced and primitive. Tyrannosauroidea includes the family Tyrannosauridae, which is the family Tyrannosaurus belongs to, but also more primitive forms like Dryptosaurus, Timberlengia, and now Alioramus. There was too little material to put Alioramus into anything more specific than Tyrannosauroidea, so there it remained for many years. Another expedition was made in 2001 to the Gobi Desert of Mongolia, but this time by Americans. The American Museum Mongolian Academy of Sciences expedition was undertaken in the same region, but at the Sagan Kushu locality. Paleontologist Julia Clark uncovered the remains of a new specimen of Alioramus from the coarse tan sandstone layers, and it was described and named as a new species due to differing anatomical details to the first specimen, and christened Alioramus Altai, referring to the Altai Mountains of Mongolia. This new specimen consisted of a nearly complete skull, neck, back, hip, and tail vertebrae, a few ribs and pieces of ribs, nearly complete pelvis with ischia and ilium, and most of the hind limbs, including femurs, tibiae, fibulae, and both feet. Thanks to this second find and the information gleaned from the first specimen, there is now a broader picture of Alioramus. Though the two specimens have been attributed to two different species, they are still rather similar, and similar enough to get a generalized idea of the animal's anatomy. Both the remotest specimen and the Altai specimen are young individuals. They had yet to stop growing, which can be seen within the bones. In young animals, most bones in the body, and particularly the skull bones, are made up of many unconnected bones. As the animal ages, these bones fuse together to provide more support and to be able to move as the bones and the rest of the animal grows. These unfused bones are evidenced by lines in between them, called sutures, that can show whether the animal has finished growing or not, thus having reached an adult size. In both of the Alioramus specimens, the bones had not yet fully fused, meaning they were adolescent. Ontogeny is a word used to describe the way in which an animal grows. It is the process by which an animal may change shape as it ages, going from a baby to juvenile, to sexually mature subadult, to adult, and finally to senior. Since there are only adolescent Alioramus to look at, it's unknown for sure how big the animal would have gotten when fully grown, nor is it known if their skulls and proportions would have remained the same, which has caused quite the confusing mess. Let's bring in Mr. Man from Animal Planet's The Most Extreme to give us a helping hand in visualizing the not-so-hefty mass of this gawky teenage tyrant. The first specimen of Alioramus was just a skull and foot, so any estimates of its total overall size were a bit lacking in hard evidence or good comparisons. The second, more complete specimen was about the same size as the original skull, making a generalized size a bit easier to come up with. The length of this animal has buzzed around the 5 to 6 meter, 16 to 20 feet mark. It could stand as tall as an average person. Since the Alioramus specimens belong to juveniles, the adult animal's dimensions are unknown, but definitely would have been bigger. It could have been only a little bit larger like the North American Albertosaurus or Daspletosaurus, or could have reached similar sizes to Tarbosaurus and Tyrannosaurus. We just don't know. Alioramus is distinct for its long, thin skull. This type of snout is called longirostrine, which is Latin for long-snouted, whereas the opposite, brachyrostine, refers to a short snout, like with everyone's favorite Carnotaurus. On the top of the snout, what we would see as the bridge of the nose is covered in anywhere from 4 to 7 little pointed projections of bone, like little horns, creating a ridge of spikes. In life, this ridge would probably have been covered in some form of keratin or hardened skin, and thus would have been much larger than the bony core we see in the fossils. What would this animal have used this for? Considering the trend of attributing the use of odd wattles, flanges, spikes, and crests to display purposes, it is very much likely that Alioramus too used these spikes as a display structure to other members of its species, especially since they were far too small and fragile to be used in a combative role, plus the skull is much too thin and slender to be used with the spikes for any kind of physical display, like headbutting. The Alioramus we do know of were immature individuals, but had already begun growing these spikes. This could mean they grew even larger as the animal reached sexual maturity. That being said, it is unknown if these specimens had already reached sexual maturity before skeletal maturity. Their presence in a younger animal could also mean they were co-opted as a signifier of age and species. The brain case was so well preserved in the second specimen of Alioramus that it could be CT scanned and a digital cast of the endocranial cavity could be made. Now, the endocranial cavity is the hole where the brain lived, but it doesn't represent the exact size, shape, and extent of the brain and its many parts. It gives a really good rough estimate of that shape though, so it's still significant. The semicircular canal, the series of tubes that are responsible for regulating balance in Alioramus, showed that the animal held its head in a slightly downturned position while alert. This downturned angle of alertness differs from many other theropod dinosaurs who kept their heads more or less horizontal, and the Maniraptorans who kept their heads even more downturned. The volume of the brain was 81 cubic centimeters, which is technically proportionally larger than that of Tyrannosaurus, as Alioramus had an encephalization quotient of 2.4, with Rexy at 2. The encephalization quotient is defined as a relative brain size measure defined by a ratio between observed and predicted brain mass for an animal of a given size. This is also based on a nonlinear regression on a range of reference species. That means a lot of gross math stuff we don't have to worry about now. What we need to know about this measurement is that it's more refined than the old brain-to-body mass ratio that used to be used to give an idea of intelligence. Unfortunately, the encephalization quotient was developed specifically for mammals, so it may not have the same results for animals outside that definition. What kind of environment did Alioramus live in? What did it use that funky-looking gray matter to hunt? What critters did it eat? Who did it come face-to-face with every day? Alioramus comes from the Nogon-Sov and Sagan-Kushu localities. The Nogon-Sov beds are pretty much agreed upon as belonging to the Nemegt Formation, but the Sagan-Kushu beds do show some differences in types of animals present, so it may belong to a separate formation and different time. Neither localities nor the Nemegt Formation have been formally radiometrically dated. Instead, researchers have used comparisons in types of animals present to determine a general age to this layer. With that, both localities, the formation, and the Alioramus fossils most likely come from the Maastrichtian age of the late Cretaceous period. So, roughly 72 to 70 million years ago, give or take a million or 2 years. The Nemegt Formation is rich in fossil material and shows a bustling ecosystem, complete with nearly every spot in the food chain. Alongside Alioramus was the incredibly fragmentary early Tyrannosauroid, Megaratan, which has so little known about it that I can't really go into any more detail other than it was one of the small to medium-sized predators of the ecosystem. These predators shared the environment with the tank-like Ankylosaurs, Cycania and Tarchia, the Hadrosaurs, Saurolophus, and Barsboldia, which formed the mid-level browser niche, the herbivorous sloth-clawed Therizinosaurus, and the Ornithomimosaurs, Gallimimus and Ceramimus, and Dinocyrus. There was also a slew of oviraptorosaurs in this time and place that were likely at various stages of omnivory, having the anatomical capacity to chow down on fruit, seeds, nuts, foliage, as well as to hunt down small vertebrates and crunch up tasty invertebrates. Their diversity is reflected in the amount found, including Avimimus, Elmisaurus, Conchoraptor, Gobiraptor, Nemegtomia, Oxoco, Nomingia, Citipati, and Rinkenia. There were the small-sized boneheads, Prenocephaly, and Homalocephaly, which nibbled on plants and insects alike. Sauropods were here too, in the form of Nemegtosaurus and Opisthocoelicaudia. Giant Ashtarchid pterosaurs soared the skies and roamed the lands for quick bite-sized snacks. Gators and turtles swam the waterways, while the troodontids Borogovia, Tochisaurus, and Zanabazar came out at night. Pecking at insect mounds or bounding across the sands at night were the Alvarezsaurs, Mononychus, and Nemegtonicus. These small theropods may have been joined by or hunted down the small mammal Buginbatar. The environment that Alioramus stalked was full of conifer forests with lots of streams, river channels, and lakes. This is evidenced by the leftover sandstone and shale rock deposits, which suggest water, presence of petrified wood from densely packed, now extinct giant conifer trees, which reflects a large canopy that would not have let large amounts of light through. Here, Alioramus also lived alongside another Tyrannosaur, a bigger, heavier, bulkier Tyrannosaur. Tarbosaurus batar is the top predator of the Alioramus ecosystem. At first glance, the skeleton of Tarbosaurus looks mighty similar to that of the North American Tyrannosaurus. This has even caused some researchers to sync Tarbosaurus into the Tyrannosaurus genus as a separate Asian species. Though there are some differences between the two, which has kept them separate. Tarbosaurus is smaller, more lightly built, was on a separate continent, and comes from a different time. How can there be two moderately large top predators living together? In order to flesh out the answer to this question, we need to take a trip to latest Cretaceous North America. Among the fossil-choked rocks of the Hell Creek Formation, two types of tyrannosaurs have been recorded. The biggest, Tyrannosaurus rex. The other is smaller, lighter, pointier, and known only from juvenile remains. The second is the infamously controversial Nanotyrannus. It was originally described as a small genus of tyrannosaur that branched off the tyrant clade earlier than Tyrannosaurus and adapted to a separate niche to avoid competition from its larger cousin. The fact that all Nanotyrannus remains are immature and most Tyrannosaurus remains are mature suggests that Nanotyrannus is really the juvenile form of Tyrannosaurus. This has gone through a rather heated back and forth in the scientific press for decades now, and a hard answer has yet to be nailed down. This is in no way helped by how many fossils of Tyrannosaurus and supposed Nanotyrannus are locked behind private fossil hunters, sellers, and collectors. Thankfully, one of the most important keystone specimens of a supposed Nanotyrannus, the Montana dueling dinosaurs, was acquired by an accredited museum and is currently being worked on as we speak. The probability is extremely high that the anatomy seen in Nanotyrannus directly morphed into that of the adult Tyrannosaurus, and that the two are one and the same. Whether Nanotyrannus is a juvenile Tyrannosaurus or it is a unique animal, the animal did represent a unique ecological niche taken by no other carnivorous dinosaur. These long-limbed, long-snouted forms of Tyrannosaur have coexisted with the larger brute force Tyrannosaurs for a long period of time during the Cretaceous period. For example, the larger, more robust Daspletosaurus lived with the smaller, lighter Gorgosaurus. This brings us back around to Alioramus. Alioramus, a smaller, lighter Tyrannosaur, lived with Tarbosaurus. Some researchers have hypothesized that perhaps the entirely juvenile remains of Alioramus may represent the juvenile form of the mostly adult Tarbosaurus remains. It would sort of fit when compared with the growth trajectory of Nanotyrannus into Tyrannosaurus. The long, weedy legs became muscular and more proportional to the thick and robust body. The long arms stayed the same size as the body grew, and the snout became more robust. This sounds all nice and dandy until you find out that young Tarbosaurus remains are known. These bones are quite unlike the skeletons of Alioramus and more like the known, extremely fragmentary remains of very young Tyrannosauruses. These young specimens of Tyrannosaurus and Tarbosaurus are younger than the stage of growth of the known remains of Nanotyrannus and Alioramus are at, but both suggest a growth trajectory that would not result in the anatomy seen in Alioramus. Instead, the growth trajectory better matches the anatomy of Nanotyrannus. Okay, so Alioramus isn't a juvenile Tarbosaurus, but Nanotyrannus is a juvenile of Tyrannosaurus. Where does that leave Alioramus? When first described, Alioramus was a complete oddity. There weren't a ton of Tyrannosaurs known, and the true diversity of theropod dinosaurs had yet to explode to the level at which it is today. Its bizarre anatomy is what gave it its name after all. It was lumped into the general superfamily Tyrannosauroidea, which basically contains all known tyrannosaurs and their crested three-fingered cousins. Alioramus got moved into the more specific Tyrannosauridae and Tyrannosaurinae in the early 2000s, as more tyrannosaurs had been found to get a better understanding of the list of characters that defined them. Enter a new, lightly built Chinese tyrannosaur with a long, pointy snoot, Qianchaosaurus. Described in 2014, Qianchaosaurus shares a huge suite of anatomical similarities with Alioramus and proved an Asian lineage of tyrannosaurs diverged from the others by taking advantage of an unknown niche with smaller size and lighter builds. With the description of Tyrannosaurus came the resurrection of the new thing is just a different growth stage of old thing argument. This time, Tyrannosaurus was the candidate of adult form for Alioramus, as the bones of Tyrannosaurus are more fused and therefore more mature than those of known Alioramus specimens. As it stands, Tyrannosaurus and Alioramus remain separate but closely related animals until more remains of either can be found that might prove their synonymity one way or the other. Alioramus, just one of the many mysteries of Mongolia, has yet to be put to rest, for there is definitely adult specimens out there waiting to be discovered, maybe by the top paleontologists of the day, and maybe even by you. Maybe you will take up the paleontological mantle and take advantage of the gumption to journey to the dry wastelands of Mongolia and the Gobi Desert to finally solve this 70 million year mystery once and for all. The mystery of the five-horned tyrant.
I want to thank my animators Adam Mitzuk or Kuzim and Tyler Addison for the animations in this video. If you like their work, consider following them on Twitter. Links in the description and comment section below.
For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, hit the bell icon for updates, like this video, and drop a comment in the comment section below. Thanks for watching. Special thanks goes to my elephant tier patrons Thea Svensson, Staniforth Hopkins, Dinosaur, Chris Frampton, Biotaverse, Arda Bayer, and Christoph Hubbinger, as well as my Tyrannosaur patrons Iron Bladesman, Henry Brennan, Danny Van Heck, and Dana Manchester.